Hey guys, welcome back. We are going to talk resistors today. So, we wrapped up when we were talking about Ohm's law here with our resistors, right? We can use Ohm's law to calculate how much resistance we need in our circuit for everything to work really nicely. Now, it's one thing to say, oh, I need 5 ohms of resistance for this to work. It's a whole nother ballgame to actually get 5 ohms of resistance in, right? So, these thingies here are resistors, and they're not nearly that big. Obviously, this is very zoomed in. They're actually quite small. But we have boxes full of these here at school. So if you're building a circuit and you want to make it a little more difficult for somebody by perhaps having extra batteries in there, you've got to do your job to make sure that you're not going to burn out the circuit. And the way you're going to do that is by using Ohm's law to calculate how much resistance you need, and then figuring out which resistor I need to pick to get the right amount of resistance. And that's based on those colored bands, the color codes. So let's hop in. Let's take a look. How do we do this? So all the resistors we have here use what's called a 4-band code. There are some resistors that use a 5-band code, so they have 5 colored stripes. We're only going to have 4. A little easier to read, usually used for smaller resistors. So this means, of course, 4 colored stripes. The first colored stripe is the tens digits. Let's say I've got 4 stripes. 1, 2, 3, 4. Let's just say red, blue, black, and gold. Sure, those are my colored strips. That's the bands that I see on my resistor. The first colored stripe is the tens digit of how much resistance you have. The second stripe represents your ones digit for how much resistance you have. The third stripe is a multiplier times something. So if I had let's say I had 200 resistance, I would have 20 times 10. If I wanted like 5,000 resistance, maybe I would be 0.5 times 1,000. So you can use the multipliers to get to really big resistances. Most of ours will just be a times 1 because we're using pretty small resistors. But just so you know, the third band is your multiplier in case you got big resistances. The fourth, the final stripe, it doesn't actually tell you anything about how much resistance there is. It tells you how accurate the color bands are. It's your percent accuracy. So people who make these aren't like, it's not exactly what it is, but usually it'll be off by 5 or 10%. So this might be 100 ohms with 10% accuracy. And so that means, oh, so this could be anywhere between 90 to 110 ohms. 10% is not very good, but it's like, yeah, you'll be somewhere in the ballpark. If I had 5% accuracy, I'd be plus or minus 5%. I would be from 95 to 105. Then we're getting closer. If you had 1% accuracy, well, then it's between 99 and 101. So if it says 100 ohms, 1% accuracy would actually be really close, right? So that last band tells you how accurate you're being. Now, for what we're doing, probably not super important, especially with small numbers. The percents don't make a difference. But if you were putting a resistor, I don't know, on a power line or something where you've got, hundreds or thousands of volts flying through there and lots of resistance, that 10% might be huge. Like, you might have to be very careful. So that's why it's marked on the resistors. So the chart on the next page will help show a little better what I mean. But let's rewrite these bands here. Red band, and we'll check it. A blue band, a black band, and a gold band. Alright, so let's see, if we were to read this exact 4-band code on a resistor, what would it mean? So band number 1 is red. So you look at your first digit, and you'd say, okay, it's red. It's a 2. My second band is blue. Let's take a look. Second band is blue. Alright, it's a 6. third band is black. Oh, look at that. It's times 1. You're probably going to see a lot of black bands on our resistors, because we often do times 1. And then our tolerance is gold. There you go. We are plus or minus 5%. So put this all together. This resistor is 26 times 1, which is 26 ohms, and it's pretty close, plus or minus 5%. Not great, but not terrible. So this code table here tells you exactly what the resistor is that you're looking for. This is how you read a 4-band code. Every single 4-band code in the world uses this resistor code table, as far as I know. All of our resistors do. And so this is something you can just Google. If you hit the Google and type in 4-band resistor code, or 4-band resistor colors, you'll get something like this showing up somewhere that'll help you, show you how to read it and give you a hand. So let's practice a few. Now, how do I know which ends to start? Is this the first stripe, or is this the first stripe? Is it red or is it gold? Oh, that's not what I meant to do. Here, let's look at our table. Often, golds and whites will be your last band. Almost always the 5s and 10s will be golds. And you say, like, how do I tell the difference between this and this? They're both yellows, right? Not quite. That is metallic and shiny. It's actually not yellow, it is actually gold. So basically what you're doing is, you're looking for shiny? Is that how you spell shiny? Shiny! You're looking for the shiny band. That's going to be your last one. So if I look here, this is my shiny band, which means this is band 1, this is band number 2, that's my multiplier. So I've got a red band, I've got a brown band, 21, times, I've got a red band, times 100, 2100, and I've got a gold band, plus or minus 5%. Check out this one here. We got like blue, purple, brown, gold. All right. Blue band, 6. Purple band, 7. Brown band, times 10, 67 times 10, add a 0 to the end, and a gold band, same as last time, plus or minus 5%. All right, let's do one more, and then I'll figure that you guys know how to do resistors. We've got green band. Okay, well, this is gold, so this is the last one. So we're going to start on the far away from the shiny one. We got green. All right, I got a 5. I got a blue. So this is 56. I've got an orange. Times 1K. What the heck? What's 1K? Oh, it's the old metric system here. 1K, 1 kilometer, 1 kilogram. It's 1,000. So this isn't 56. It is 56,000. Oh, and then we've got gold again. And gold is always plus or minus 5%. This is a big resistor, 56,000. So what do these numbers mean? Just as a quick reminder, ohms. It's our resistance. So if we go way back to our Ohm's law, we needed 12 ohms. So I need a 12 times 1 ohm resistor. What is that going to look like? Let me erase all this stuff for you. A 12 ohm resistor would be 1 2, 12, times 1, and then probably a gold or a white. So I would want to see, do I have brown in here? We'll call that brown. I'm looking for a resistor that has a brown stripe, a red stripe, a black stripe, and a gold stripe, shiny gold stripe. There. If I can find a resistor that looks like this, I have my 12 ohm resistor. And that would work with the scenario that we had in Ohm's law. I think it was like a 9-volt battery or something. Yeah, that would be, or if I have a 9-volt battery and I want to run this tiny little bulb, I used Ohm's law to calculate what I needed, and then I read the resistor code to find the resistor I need to make that circuit work. So that's it. That's resistor bands, guys. That is the system of language, if you will, of how to read and decode resistors. So thanks for listening, and hopefully this was helpful. See you next time.